I had to go get it, and I had to test it. So what I do is I measure the stuff. So for this, I kind of, while I was sitting at the conference or at the show, I kind of estimated what it's going to be, and I kind of, in my mind, playing around with how I would get this thing to connect, where I would connect it to. So the most logical place for me seemed to be on the arm of this, because it's like right there, and it's really out of the way as long as you're not touching anything here, right? I could have put it on the legs too. I did do like some bigger ones, but these bigger ones were like way too big for the legs because I overestimated that. So the first thing you do is just try to figure out the mechanics of how it works, the mechanics of how you're going to attach the stuff. And then once you have that, then you go through and measure it. So like for this, I just took a ruler and I held it up against the side and I said, that's 3/4 of an inch and this one's a 1/2 inch. So then when I come into Maya and I'm trying to line this stuff up, I go to my little running man down here and I go to settings and I set this to inches. Okay, you can set it to centimeters if you're using centimeters or millimeters. Whatever you're using, that's what you can set it to. Okay, so this is the size you're going to print your stuff out. Just so you can get an eyeball of how long things take, this is about a 1/2 hour. Okay, this, where's my other one? Oh, right here. So they're basically just a little bit bigger. This was the first iteration. Some reason they printed really tall, so I had to shrink them, so that's why we got that one. So it takes about a 1/2 hour for something about half this height. Okay. The heads that I've shown before, not this one, because this one is printed wrong. This is like the first head I printed, and it turns out that he's solid, so it takes a lot longer. They typically take about 4 hours for a head about this big. Your helmet took about 6 hours, just because of all the detail in it. Your head took about 4 hours also. Okay, so heads typically take about 4 hours is what I gauge, and that's about 3 inches by 3 inches by 3 inches. So when I'm trying to figure out how big stuff is, I'll go into here and make a cube. And now all my grids are 1 inch. So this is an inch, that's an inch. Everywhere you see the grid mark is an inch. This cube is an inch. So when I had these little clips, and I knew they're 3/4 of an inch, I went here and I said 0.75. Now I know that that's 3/4. So that when I come into my top view and I'm lining my stuff up, I know that I can scale this right there. Okay, because this is the inside, right? That's the inside part of it is going to be 3/4. So I have to make sure that that is no bigger than 3/4 of an inch. And then the other one was a 1/2 inch, so then I could just take this and duplicate it and shrink it down. Oops. Need to get back to the original. And then I can take this one and shrink it, scale it until it fits about there. Now it just so happened on the other one that I kind of positioned them better. That way when they print, they're basically printing inside of each other, so it makes it easier for the printer to print instead of going like way across the print screen every single time it has to move. I can even rotate this.
Do we scale it in the printer program?
You can scale it up uniformly or down, but it's not accurate. You don't know how big it actually is. Okay, so here I'm basically locking in, this is the size I want, so that when I go to the printer and it says, you know, this is going to, sometimes it'll say, do you want to scale it? And you hit yes, and it makes it either really huge or really small, and then you have to figure out what it's doing. Because we have to go from Maya into an exporting program into another program, and sometimes those things don't always line up with the increments. Okay, so like on this one, when I printed it, my original size was this, 3/4 of an inch. That's how tall this thing is, or an inch tall. When it printed like this, because in the printer, it was setting it to millimeters. So it thought that this was this size. And I actually had to just cancel it because I was like, that's way too big. So then I scaled it down, realized what it had, and I had to convert it inside the printer. So the easiest way is just measure your stuff. Okay, so now I have these 2 blocks that I know that these are the exact size that I would need for this type of thing. Then I can go to export it. There's a couple different ways. In 2016 extension 2, there's an export selection, so you can do that. Only if you have the STL option. Okay, you have to send your stuff out as an STL. That's what the printer reads. So you have to save it as an STL. So I can save this as a tripod bits. There we go. Okay. Now these are two small pieces that are basically solid objects. There's no moving pieces. There's nothing fancy with this. If I had something a bit more complex, like let's say this guy here. So this is a little character that I built. It's hard to see, but on the shield here is the Macomb emblem. And then written around here and under here, it says Macomb Community College, Media and Communication Arts, and then he's holding like a pencil. So he has like, that's his weapon and his shield. What? So if I go to where that guy is, or he's in Maya 2017.
Is there a way for like measuring in the program that displays it?
Yes, we can do that too. What I just touched. Under Create, you can go to the Measure Tools and go to Distance Tool. And that way you can kind of just hold down V and click and click. And now I know that that is 0.4 inches tall. Okay.
Can you select like planes and edges and then click like, is there like a measure between?
No. No, you just have to use that Measure Tool to figure that out. That's why I'm holding down V, so it snaps it to this corner.
Oh, okay.
And it snaps it to that corner. All right, so once this, still thinking. Let me just save this. It's a very descriptive name. I'll forget it later. There we go. So let's just say for fun of it, I have a cube that I want to create, and then I have a sphere. Like that. And then there we go. So I want to print, let's say, this object. If I sent it to the printer like this, it would try to print everything inside there. It would actually try to print like this underside too. It doesn't differentiate, saying that this is on the inside and that's on the outside. So the one time I allow booleans is for stuff like this, because what it does, it actually goes through and it cuts off all that stuff we don't need. But what I like to do first is prep it. So like this guy, he has way too few divisions. He has a lot of divisions. So I need to find that middle ground so that they're both the same. So if I go to Mesh Smooth, which we've gone to before, you see it rounds it off. We don't want that. If I go to Mesh or Edit Mesh, Add Divisions, this one doesn't round it off. It just adds divisions to it. So you can just crank this up. There we go. That's way too much. Maybe 3. That's good. Okay, so that seems pretty similar. So now I can use booleans. Mesh booleans union.
Why is it important that they're similar in division?
Otherwise, the booleans will act even weirder than it usually does, and you might get some like streaks across your surface. Okay. By having these divisions here, it has these extra lines right on top where they could help meet up so that they don't do anything funky. Now, the other thing I would do when I do this is I would triangulate it. And what this does is it adds extra divisions that help the booleans become more realistic and more accurate, because it's actually lines connecting each point to where it needs to go. So now that I have this, then I could send this to the printer. So that I could say export selection, save it as an STL. Now new to 2016.5, yes, is Send to Print Studio. So on these computers, you can do it, but it's going to want to download it, and you have to install it and whatever. On your home computer, same kind of thing. You'd have to download it, install it. But this will give you a, hold on, to orient myself to a program we're in. This will give you an idea of what your stuff is at. So I can take this and say move it to the build surface. There we go. And so that's how it's going to be oriented. Now, the idea is that you would have a printer hooked up right to it, or you would have some sort of print service where you could send it off to be printed online and then mailed to your house. That's a possibility also. For this, I simply just go to File, Export Selected, and then I'll save it as an STL to my folder. Okay? And then when you're on the printer, which I'll show you when you get your object ready to print, you can just load the STL and then print it off. Okay? Now to show you the other guy here, because he was a bit more complex, new logo holder. What? Where did I say he was? New logo holder. There he is. So now he is huge in the scene because he is set to inches. Okay, but my scene is set to centimeters. So when I bring him in, he's huge. So if I set this back to inches, then he doesn't seem as big. He's still big, just not as big. Okay, he's definitely should be scaled down. Oh, because I imported him, he wouldn't scale, whatever. Okay, so there he is. So this gives you a good idea too of how big he's going to be because each line is an inch. So I know that this is like he's going to be about 2 inches wide. You can see the Macomb Community College, Media and Communication Arts. So same kind of thing. If I zoom in to the shield, you can see how each one of these things is actually cut out because of the booleans. Okay, so you have to do that for everything in here. Otherwise, it's going to print it like it did this one. And if you feel this one, he is incredibly heavy because it literally printed the entire head on the inside. It printed the glasses. You can see they kind of like broke there a little bit. And his eyeballs are also printed on the inside. So it's like if I were to cut him in half, you would see all the pieces in there. It just wastes. He's dead now. He just wastes some of his stuff. He didn't break. You can't break a Macomb person. Okay, so here's the iterations of this, because it doesn't always go smooth. Like every single thing you do inside Maya doesn't go smooth.
Nothing I do inside Maya goes smooth.
Right, and that's not just for you, that's for everyone. So somewhere on here, there he is. Oh, that's a different one. There it is, okay. So on here, you can see all the different shapes that I have, or all these are booleans together. And triangulated. I believe that's the one. Yeah, so I had to create every single piece of this and do the same kind of trick, booleans it, and then set it up. Now when I went to do him, watch what happens when I booleans him. So I do the booleans union, and you see that he disappears, okay? So booleans works with normals. It doesn't know which side is out or which side is in. It just uses the normals to do that. So I'm gonna hit undo, and if you look at these little clasps, you see they're black. Before we just did this. We'd say use two-sided lighting, and then we would just ignore it. Well, that's the inside. So Maya thinks that those two surfaces are outside, so it's keeping like the other pieces of this. So I'm going to go to Mesh Display and reverse this. Now if I go here and go to Booleans, now it's going to do something else too that we'll see in a second. And I union this. Okay, now it actually shows it, but you'll see that he is also really blocky. So before I do any of these booleans, I have to make sure that if I hit 1 on everything, that's what it's going to look like. So I have to make sure I smooth it as smooth as I want it to go. So smooth that, not that much, or not that little. Maybe 3 should be good. Oops, 3. There we go. So he's nice and smooth. Booleans union. There we go. And now I should be able to connect that to the shield. Now even like the text, when you create text inside Maya, oh no, where'd you go? We'll ignore that. He shouldn't do that, but for some reason he's doing it. He didn't do that before. Anyway, let's just skip to this. And you create type inside Maya. As the geometry, the front face is always flat. So if I try to do a booleans on it, or I try to do a smooth, or try to do anything, it just freaks out. Okay, so you can see how this is totally flat here. And if I were to, I don't know, just create a cube. And then I went to Mesh Boolean Union. It may work the first time, perfect, it worked. But as I add more text and more text and more text to this, like Macomb Community College, Media and Communication Arts, it's going to become harder and harder. And just like the other guy disappeared, it is very possible that the guy will just disappear, or your text will disappear, and it just won't work. So what you should do in all cases is add divisions to it. So doing the triangulate is one way to add divisions because it helps define the surface better. The other way is using this edit mesh add divisions, because that really helps too. Same thing with this, adding more divisions to this. And then doing your booleans union. There we go. Okay. So now this kind of stuff would obviously print. I shouldn't have gone through that side, whatever. Okay, so the first step in this, like I said, is measuring it, getting it lined up, and then you do the booleans and you're saving it as an STL. Just to show you some other stuff that I've built.
If you did like booleans and you did different, would it have like...
It would subtract it out.
Would it print that way?
Mm-hmm. So if I undo, I'd made a new scene, so it's not going to undo. So I click this, mesh, booleans, difference. So it would print with that hole right inside there. And you could do that with text or anything. Let me go to my G drive here and look for my phone folder. There it is. Oops. So here's a phone holder that I built. And the premise of this is that you're able to have this little ramp here that you can, like extra pieces, that you can turn if I put the pivot in the right spot. There you go. And then you can turn this, and then you can rest your phone right on here, and then you're able to actually just like have your phone sitting on the table. So my old phone used to have a little connector in the back, so I could do that, and my new phone does not. So I needed obviously some sort of device that could do that. So you can create moving parts. You just have to think of a way to do it inside the 3D printer. So with this one, you can see that I made these like little nubs. Okay, so there's like this. Let me isolate this. There you go. So I used booleans to make these little nubs in here, so that I could then make this little ramp that also had nubs on the outside, and then I could open it up and then actually rest my phone inside there. Now I should have made this a bit bigger because when I actually printed it, it was a bit small. So that's where you can come in and just start tweaking stuff. So I could just say, well, I need this to be bigger, so maybe I just take this and pull this down, or I grab this and pull it out. And now I've made this thing bigger so that it would be more, ready to use. I also would probably want these to be bigger too, so that's another iteration of it. But there's lots of different ways that you could do this kind of stuff to make it work. That one. So this is another one of my fun things that I built. This is my phone holder for my car vents. So here these slip into the car vents. My phone would slide into here, and then there's a little tray. Okay, now again, I started off with my measurements. I grabbed my phone, how big is it this way, how big is it this way, how big is it that way, and I just built a little model inside of here. So I may even have that, I delete stuff all the time. So I just went to a cube, and I literally just sized it up to be the exact dimensions of what my phone was, so that I could test it out and make sure that it's hitting in the right spots. So one of the things I wanted to not do is, if I use this, I want my audio cable and my charging cable to be plugged in. So I had to make sure that those two areas were not blocked by anything. So I lined that up too and made sure it wasn't going to interfere. Also, I want to make sure that I could easily lift this out and turn it, and then I switch to my side view. I probably turn it just a hair more. There we go. And I'd be able to kind of slide this out. I think it's a little bit thicker than my actual phone. Okay. So this is a great way to kind of concept how this would actually work. Or I could slide this in from the top and then use it that way too.
If you measured out where your aux cord was and that distance setting, does it show you as you're going down where you're at?
Yeah. So I could do, I'm on the measure tool where it went right here. So let's just say I measure this to this. Oops. I could just grab this and move it wherever I need to.
Oh, okay.
So as I'm moving this down, I could say it's 8 inches from the top. There we go. Or this one here is right there. Oops. There we go. Okay, so I can measure it exactly where that needs to be, and so then when I print it, it should print pretty close to where it's at. So it's one of those things that's just amazing, I think, anyway. I think it's amazing to be able to come up with an idea at this meeting, and then to create the idea, and then to actually have that thing that you've created. And so this one is something I built. I built this phone thing. This is probably my best one because it's the one I use the most, but I did change it because this thing was a little bit too flimsy. So I actually made it like this now. So this comes down like that. Still doesn't hit the other cable. And then I deleted that. I filled this in. Filled that in. And then I just extruded these out like that. Okay, so now these are a little bit more rugged than the other ones, so they actually last a bit longer, by a lot longer, I mean. There we go. So those don't break as easy. And then I also added a guide cable so that instead of your cable like dangling off the side, which could hurt the port, I have a little guide there so the cable actually runs along the top of it. So, I mean, for me, it's like, it's an amazing thing to be able to do this kind of thing, to think of all the areas in your life that could be improved, not drastically. I'm not talking about changing the world, but you're changing your own life. It's just little things like this, you know. I don't have my other one here. No, I don't. I made like a steering wheel holder, so you can put this hook on your steering wheel and you can put your phone right in there. So if you're sitting parked somewhere, you could have your phone held there, or your Kindle, or your whatever. That way you don't have to hold your stuff, which is, I think, again, awesome. And that's important. Okay, so I wanted to show that because it's important. It's for if you're staying in 3D, if you plan on getting a job in 3D, this stuff isn't going to go away. You have to keep doing this stuff. You have to keep pushing it and making sure you understand not only how to build it in 3D, but then how to actually manufacture it so that you can get it out there. Now the next step in something like this is, let's say we were going to go to actually build it and sell it, is this is a test. This is our test to make sure it works. Then we would take it to a manufacturer who would create it out of like a harder plastic, and they could basically just create, you know, chocolate mold type things where they just like squirt plastic in there. Then they can have like 60 of them or 70 of them or 1,000 of them at a time, right? So that's the idea. That's the goal of this kind of thing. And if you created something like this, you could patent it and you could make money off of that patent.
What other materials do they 3D print in?
Right now, it's just plastic is what we are printing in, just this hard plastic. But they have other stuff, which is, that's not it. 3D printed injection. So they have these other ones, which are not there here, which are more of like rubbery type materials, which are kind of like that stuff. And like rubbery. There we go. And you can also print different colors. Now what's neat too is a lot of these, like obviously not the little thing, you wouldn't really do that to, but something like this you could actually 3D print, and then you could put it, make a mold of it, and then pour basically any metal or any material you want. So you could pour like liquid latex into it and create a latex model of your model. You could pour aluminum into it and make like a steel or aluminum model of your head. That's the other stuff I've been looking at.
Is there like an easy way to like invert it?
To invert it, you could actually use booleans to invert it too.
Like that's what you'd have to do, right, to make a mold?
Yep. Yep. This was something for my dad. This doesn't, you know, improve his life drastically. But again, it was something that I could play with to see how the printer worked and its limitations. So this is a pot pan lid holder, right? So you take your your lid off of the pan. It's dripping with moisture. Where do you put it? Right there. It just rests right here, and there's a little reservoir that can collect the water. Again, not revolutionary, but it's a fun thing. And they're actually selling these online for like $40. Yeah.
She likes to stand things up.
I do.
His dad asked him for that one.
Yep.
So okay,
runs in
so
the
when we
family
were
then.
Need a way to store my
when
lids.
we were doing that presentation,
Not far off.
that hand that they had, was that
Right.
injection? or-
Yes, that was an injection type printing.
Okay.
Their other one is carbon, I think it is. Yeah. So this one is pretty awesome.
Can we 3D print stem cells?
We cannot yet.
No.
We can't. I'm sure someone can.
No, they've already
Plastic.
printed artificial organs.
Right. There you go. Look at this. How this one prints. So there's basically, I don't know how the full thing works yet, but there's this little device, and it slowly moves up as it moves up, it's actually creating the object right there.
It's magic.
Isn't that from a laser on the inside, like solidifying it? and
Right.
it's being pulled out?
I believe so.
Are you? Is McCollum gonna get one of those?
Yeah, right.
Well, not yet. We'll have to wait till they come down in price. They were like $500,000.
Yeah.
Oh, Jesus. Crazy.
And this is, if you look at the little
$500,000.
asterisk here on the side, this is 7 times speed.
No, they take forever because I interned at a company who did 3D printing,
Mhm.
the big three, and it was a laser printer. Like you see this pool of liquid, and you see this laser etching everything in,
Right.
and then like a day later, you'd see the platform rise up, and you'd see the object just printing. It's like, wait a minute, what? How?
Right. It's insane.
What material
metal.
is that?
I have no idea. Some sort of carbon material. What it says.
But then I also remember reading NASA did 3D printing, I think with steel. It was a metal that they 3D printed with.
Right.
And then there was a hospital that 3D printed artificial organs using cells.
They 3D print houses with concrete now.
Yeah, I know.
I'm serious.
Yeah,
I
I seen
saw
it.
that.
House made, man.
This one is pretty cool. And this stuff is like, this is 2011, but the 3D printers, like you can buy one at Barnes & Noble now because it's a crappy one still, but it's a good entry level one. It's like $250 entry level. So this one, they're showing the application. There's a scientist or an astronaut out in outer space. He needs a specific tool. The engineer on Earth can scan the 3D tool, send it to the astronaut up there, and the astronaut's 3D printer can print out a fully functioning working model of that tool that he then has.
You didn't bring a wrench.
He didn't bring a wrench. Well, their example is a wrench because they want to show. There it is. Let me go to.
I think those are 3D print discs that you like spinal cord discs.
Yeah. Well, the dentist is printing up teeth right now, right?
Yeah.
I saw that.
My mom watched them modeling it. She sent me a Snapchat. She goes, "Is this what you do?" I'm like,
Yes.
"Yeah, mom,
Yeah.
that's what I do."
Model T.
There it is.
All day, every
So
day.
right here he's scanning it. So this is him scanning the 3D model, and it actually goes through the geometry. It goes through the metal to figure out every little bit of inner workings of it. Then when it prints it, it basically just comes out of this dust. And there it is, and it works.
What kind of scanner?
Exactly how it works.
I don't know, it's some crazy scanner. I think it says in here.
It's good.
You just have that little one, right?
What? No, we have big ones. The big ones down the hall.
No, the scanner.
Oh, the scanner? Yeah, yeah, we have our little scanner. The one that doesn't work really good. Yeah, I don't think it says it. But they're even printing, MIT is printing glass. I mean, it's not anything crazy, but they're still printing like glass. Once they can print metal, which they're doing now, then they can actually print like full-blown circuitry. So then you imagine that you have a phone. Now your phone can actually be printed because they have metal components, plastic components, all these other things inside of it. So I believe it's important to know some sort of 3D printing. So one of your additional assignments is just to take one of your models, not an entire scene, but just take one of your models that would look good 3D and print it up, okay? If your building is flat, that's not a good 3D model. It has to have some detail in there so that you can see it. So do that over the next couple weeks, okay?
I can do another one.
Yeah, you can do another one.
No.
Can I print a
You
solid
got your one.
Pokeball?
You got your one.
A what?
We have
Like a
years
Pokeball,
of my
but
one
solid.
That's all we get apparently.
Uh,
I actually
No.
chose my counter.
We can't print solid because it uses up so much stuff.
Yeah, did you feel the head? It's
Cover
like
kitchen
so
that we have to
thin.
our counters and
Okay, that is
the
pretty
top
good.
Yeah.
cover.
That's how heavy I want my Pokeball.
Right. You can if it's this big.
Okay, which one